Students, let us solve this Irodov problem number 1.50. A solid body starts rotating about a stationary axis with an angular acceleration beta equal to beta naught cos alpha, where beta naught is a constant vector and phi is an angle of rotation from the initial position. Now, what is given? The equation is beta equal to beta naught into cos phi. What is this line? This line is beta naught is a constant vector. So in the question, the given equation is not beta equal to beta naught cos phi. This is not a magnitude equation. This is a vector equation. So beta must have a direction. Now find the angular velocity of the body as function of the angle phi. We have to calculate the omega as a function of phi. So we have to calculate the omega vector, not only omega. So how to do that? Because this is a vector equation, so we must take count of the direction. The beta naught is a constant vector. It means the direction of beta is in the direction of beta naught. But the multiplied number is cos phi. It either can be positive or negative or 0. So the direction of beta have three possibility, either in the direction of beta naught or in the opposite direction of beta naught. Now let us plot the equation of beta. This is a cos equation, so the maximum value of beta is plus beta naught and the minimum value of beta is minus beta naught. Now this is first coordinate, second coordinate, third coordinate, fourth coordinate. So this angle is 90 degree, this angle is 180 degree, this angle is 270 degree, and this angle is 360 degree. Now in first coordinate, cos is positive and at 0 cos is maximum. So the graph comes like this. After that, the graph is the graph of cos theta like this, then this, and then this. Now in this part cos phi is positive, so in this part the direction of beta is in the direction of beta naught. In this coordinate, second coordinate, cos phi is negative, so the direction of beta should be in the direction of minus beta naught vector. In third coordinate, direction of beta should be in the direction of minus beta naught. Or in the fourth coordinate, direction of beta should be in the plus beta naught direction. Now first calculate the magnitude and we count the plus minus direction according to the coordinate. So beta as a magnitude should be equal to beta naught into cos phi. We can write beta as omega into d omega divided by d phi should be equal to beta naught into cos phi. Now omega d omega should be equal to beta naught cos phi into d phi. Integrate this. Initially when phi is 0, when phi is 0, there can be it is not given from initial position. Initial position I can write it as 0 but omega I write it as omega naught, or let me call it initially omega is 0. So at random angle phi omega is omega. So it should comes out omega square by 2 should be equal to integration of cos phi is sin phi. So beta naught sin phi from where to where? From 0 to phi. So omega square by 2 should be equal to beta naught into sin phi. So the equation of omega is under root 2 beta naught sin phi. 2 beta naught sin phi. Now What is the direction? The direction of omega should always be in the direction of either beta or opposite to the beta, because axis is fixed, a stationary axis is fixed, so the direction of omega can be either beta vector or minus beta vector. So we can write vector omega as first its magnitude part. So its magnitude part is 2 beta naught sine alpha, and the direction part is plus minus beta naught k cap, beta naught k cap. So this is the vector of omega. Now we have to plot this equation. How to plot this equation? So this is a omega square sine phi equation. The power of omega is 2 and this is sine phi. So now see this. Omega square by 2 should be equal, omega square should be equal to 2 beta naught sine phi. It means that sine phi cannot be negative. Sine phi should be positive. But from the direction we can count it as plus minus both. So omega can be equal to plus minus under root 2 beta naught sine phi. So the plot is more like that. In the first coordinate, in the second coordinate, in the third coordinate, and in the fourth coordinate. In the third coordinate, graph of sine theta is like this. Now we have to take the root part. So root part is more like this equation. The root part is more like this equation. In the next part, this is like this, again this, and this. Now we have to count both plus and minus. So in this coordinate, both plus and minus. So the equation is, so the plot is like this. We have to count both plus and both minus. Both plus and both minus. Now we can eliminate some part according to the given equation, but there is no need at this stage of 11th and 12th class. We don't need much detail about these plots. So the magnitude part is this, and this is satisfactory answer at this level.